undetermined coefficients, use the method of undetermined coefficients to solve the differential equation d squared y over dx squared minus 7 dy over dx plus 10y is equals to x plus exponential 2x, given that when x is 0, y is negative 1, and dy over dx is 0. Are we together? Now, we've been told to use the method of undetermined coefficients, so we want to use the D operator method. So, the first thing, we have this is an non-homogeneous second order ordinary differential equation, isn't it? So when you have an non-homogeneous second order ordinary differential equation, then you let y to be u plus v. You let y to be u plus v, where u will be the complementary function and v will give you the particular integral. So you go to your initial equation where there is y, the first part you put u where there is y, isn't it? And the second part where there is y you put v. So where there is y, when you put u, you are going to have d squared u over dx squared minus 7 du over dx plus 10u. So where there is y, we've substituted with u. Then it is plus. It is plus. Now where there is y, we put v. So where there is y, you now put v. Meaning we are going to get d squared v over dx squared minus 7 dv over dx plus 10v. Where there is y, we now put v. To be equals to, so we start with 0 plus x plus exponential 2x, isn't it? Are we together? Yes. So the first equation we compare with 0, the second equation we compare with the function f of x. Are we together? The whole of this, x plus exponential 2x, the whole of it is the function f of x, isn't it? Which is a superimposition of a polynomial function and an exponential function. Are you seeing that? The first part, which is giving you the complementary function, must be equated to 0. Are we together? And that's where we are going to use the D operator method, isn't it? So start equating the first part, which is d squared u over dx squared minus 7 du over dx plus 10u is equated to 0. So that one forms equation number 1. Are we together? Then equation number 2 is the second part, which is d squared v over dx squared minus 7 dv over dx plus 10v is equated to the whole of that function. Are we together? And the whole of that function was what? It was x plus exponential 2x. That forms equation number 2. Are we together? So we want to start solving equation 1. Equation 1, you can see, is a homogeneous second order ODE, which will give us the complementary function, isn't it? So the first case there where we get the complementary function, we have what? We have d squared u over dx squared minus 7 du over dx plus 10u is equals to 0, isn't it? Now using the D operator, what do? Where there is D, you substitute with the d dx, isn't it? Then it means d squared will be d squared over dx squared. That is the D operator method, isn't it? Are we together? Yes. So here we have d squared over dx squared, that one becomes d squared, then times this u which is here. So you have d squared u. Are we together? Then move on, minus 7 d over dx is d, isn't it? Then times that u which is there, so it is du. Then it is plus 10 u is equals to 0. Then after that, we now substitute d with m, isn't it? To give us the auxiliary equation, isn't it? Where there is d, you now put m, you are now going to get m squared u minus 7mu plus 10u to be equals to 0. Where there is d, you now put m. So from there, u is now a common factor. You are eliminating d with m because these, the derivatives, cannot be solved quadratically, isn't it? So from there, u is a common factor. If you factorize out u, you remain with m squared here. Here you remain with minus 7m. Here you remain with positive 10, isn't it? To be equals to? So either u is equals to 0 or this second factor is equals to 0. So this second factor, which is m squared minus 7m plus 10 is equals to 0, gives us the auxiliary equation. Are we together? So we now need to solve the auxiliary equation. Are we together? So here we get m is the quadratic equation, that is minus b plus or minus square root of b squared minus 4ac over 2a. Isn't it? Can you now start substituting the value of a, b, and c? So b is negative 7. So negative of negative 7, you get positive 7, isn't it? So that is positive 7 plus or minus b squared negative 7 squared is positive 49, isn't it? Minus 4ac, 4 times 10 times 1 is minus 40, isn't it? Over 2 times a, 2 times 1, like that, isn't it? So you will find the first solution of m, 49 minus 40 is 9, isn't it? It's 9. So square root of 9 is 3. So the first solution of m, which is m1, you block the negative sign. You have 7 plus 3, isn't it? 10 divided by 2 is? Then the second solution of m, which is m2, you block the positive. So 7 minus 3, 4 divided by 2 is 2. So what do you have? You have two real solutions. Are we together? So when the solutions are real, what was our equation? It was u to be the function of x, isn't it? So what will be the solution of u? Remember, it is the u which is the dependent variable there. Are we together? When you have two real solutions, it is a exponential, the first real solution, u 5x, isn't it? The independent variable is x. Then it is plus the second constant is b exponential 2. Are we together? Exponential 2x. So the first solution 2 is there, the second solution 2 is there, the first solution 5 is there. All the solutions were real. So when the solutions are real, this is the general solution of a complementary function, or it is the general solution of a homogeneous second order ordinary differential equation. So after we found u, we now go to the second part. This, isn't it? Are we together? So here we found u to be a exponential 5x. A exponential 5x plus b exponential 2x. So we now want to use this space to solve the equation Roman number 2. We are done with Roman 1. Are we together? Are we together? Let's move to Roman 2. We are done with Roman 1. So Roman number 2, we had what? We had the Roman number 2 will give us the particular integral, isn't it? Yes. So in the particular integral, what do we have? D squared v over dx squared minus 7 dv over dx plus 10v is equals to x plus exponential 2x. Are we together? So after that, you now let what is your choice for b, isn't it? What is your choice for b? So you can see, b is going to be having two parts. The first part here is a polynomial. The second part here is exponential. So you see, b is going to be b1 plus b2, isn't it? Because b1 we are going to choose for a case of a polynomial, isn't it? And b2 we are going to choose for a case of an exponential function. So can we start by getting this b1? Remember, a polynomial, for you to get b1, a polynomial is in which form? A plus bx plus cx squared plus dx cubed in that order, isn't it? Are we together? See, that is the standard form of a polynomial. Are we together?
Yes.
So from there we now want b1, isn't it? what is V1? You check. It is X, meaning it is reaching where X is. Are you seeing that? So it means in V1 you are going to have A plus. You must reach where X is, and X is reaching here, isn't it? Are you seeing how to choose a polynomial? So in polynomial, we are going to choose A plus Bx because the highest power of X we must reach is 1. Are we together? So you must exploit everything behind at the back. Okay? You are done with the polynomial. You go to the second part, V2. What is the choice of V2? V2 is where we have exponential 2x, isn't it? So you check. Polynomial function, you don't check, is this in the complementary function? No, because you know in the complementary function, will always be in terms of trigonometric function and exponential functions, isn't it? So you cannot check a polynomial in the complementary function. Are you getting there anyway? The complementary function will always have trigonometric and exponential functions, isn't it? Then now let us go to V2. What do we have in V2? Exponential 2x. So we are going to choose k exponential. Then you check. Is this exponential 2x in the complementary function? You don't look at the constant, just look at the function. See, exponential 2x is there. Meaning you now add x to it, isn't it? Are we together? Then you check again. Is x exponential 2x there? It is not there. So if it is not there, that is the choice of b. Are we together? So what is our choice of b in general? V is now v1 plus v2. And v1 is a plus bx, and v2 is plus kx exponential. Ladies and gentlemen, now you see we've chosen everything. Isn't it? So you start, we have to get dv over dx, meaning we differentiate it with respect to x, isn't it? So what is dv over dx? If you differentiate a constant, you get 0. If you differentiate bx, you remain with the b, because with respect to x, isn't it? If you differentiate this, what do you have? See, you have k product rule, isn't it? If you take exponential 2x step, and you differentiate x, you get 1, isn't it? Then plus, now you take x step, and you differentiate exponential 2x, you get 2 exponential 2x, isn't it? Times x. So you get 2x exponential. That is differentiation by parts, isn't it? By product rule, I mean. Differentiation, product rule. Are we together? Tuko pamoja? Where you let your u, you let your u to be x, you let your b to be exponential 2x, isn't it? So the first part will be what? If you let, you have uv plus uv, if this is prime, b is prime the other side, isn't it? So if you let your u to be x, u prime will be 1, b will be exponential 2x, you end up with this, isn't it? U will be x, b prime will be 2 exponential x, if you multiply them, you end up with that, isn't it? Are we together? Good. Those are from differentiation, we don't dwell with them, they're just things you now apply, you dealt with in the previous topics, isn't it? So after that, open that and take k inside. dv over dx is b plus k exponential 2x, k multiplies everything inside the bracket, isn't it? Then it is plus 2kx exponential 2x. Are we together? Move to the next one. We now differentiate it for the second time. D squared v over dx squared. So you start, if you differentiate b, you get 0, because it is a constant, isn't it? If you differentiate k exponential 2x, see k is a constant. If you differentiate exponential 2x, you get 2 exponential 2x times k exponential 2x. Are we together? You go on. If you differentiate this plus 2k, you take plus 2k outside the bracket. Then you are differentiating x exponential 2x, product rule, isn't it? Yeah. If your u is x and exponential 2x is b, what will you get? You will get exactly what you got here, isn't it? You get exponential 2x. If you differentiate x to get 1, then the other one, if you take x step to differentiate exponential 2x, you get 2 exponential 2x times x. So you get 2x exponential 2x. Those ones you dealt with in the previous topics, isn't it? So from there, open that bracket, what do you have? D squared v over dx squared is 2k exponential 2x plus 2k exponential 2x, 2k times that, 4kx exponential. So have you seen you found everything? After finding everything, what do? So you substitute them back in your equation. Are we together? Yes. You substitute them back in your equation. So look at this. This one is going to be very simple. Substitute them back. Let me have this part to substitute them. I only leave this down as solution here, isn't it? I substitute them back. So the first one, d squared v over dx squared, what have you found? You found 2k exponential plus exponential 2x plus 4kx exponential 2x. You are done with this, isn't it? Are we together? Then the next one is negative 7 times dv over dx. So negative 7 must multiply the whole dv over dx, isn't it? dv over dx, you found this. So multiply all is sum by negative 7, isn't it? So start. Negative 7 times b. Negative 7b. Negative 7 times this. Negative 7k, isn't it? Negative 7k exponential. Negative 7 times this. You get negative 14k x exponential 2x. Are we together? So you are done with that. Then you move to the next one is what? Plus 10b, meaning 10 times the value of b, isn't it? So what is your b? So this was your b. So you multiply all the terms of b by 10, isn't it? Are we together? So start. 10 times a plus 10a. Then you go again. 10 times bx plus 10b plus 10bx, isn't it? Then you move again. 10 times this plus 10 kx exponential. Then the whole of that is equals to what? x plus exponential 2x, isn't it? Are we together? It's x plus exponential 2x. So having gotten that, we need more space. So UAU, just put UAU here for us to use this space down there. UAU was a exponential 5x plus b exponential 2x, isn't it? So we want to use this space down here. So start. You are only comparing the ones you can see. Are we together? This side we have x, meaning this side you only compare the coefficients of x only. Are you seeing that? So look here. These are exponential. See, there's no x here. Are you seeing? There's no x there. We don't need that. There's no x here. We don't need this, isn't it? See, there's x here. Are we together? So look at this term. So it means it is only that term you compare to x. The coefficient of this term is 10b. The coefficient of x there is 1. Are you seeing? So you are comparing 10b is equals to 1. Because the coefficient of x there is 10b, the coefficient of x on the other side of the equation is 1. Is that okay? Is that okay? So you have 10b is equals to 1. Are we together? So what is the value of b? 1 over 10. Because there is only one coefficient of x on this side of the equation. Anything which is not on the other side of the equation, we are not interested in. Are you seeing that? So automatically you can see a is 0 because there is no constant term on the other side. Here if you have 10a, is this a constant term? Are we together? Is this a constant term? A is not 0. There are more than one constant term. I've seen another one. There's this one. Senor. Unaona hii? So what is the value of a? Look at this. This is negative 7, negative 7b and positive 10a. So it is minus 7b plus 10a is equals to 0 because there is no constant term on the other side. Are you seeing that? See, there is no any other constant term. There are only these two. Meaning this positive 10a and negative 7b, all of them is equated to 0 because the constant term on the other side is 0, isn't it? Is that okay? So what do you get? You found b. b you found to be 1 over 10. If you take this on the other side, you get 10a is equals to 7b. Negative 7b going down side is positive 7b, isn't it? Are we together? So what is a? Where there is b, put the value b. 7 times 1 over 10, it is 7 over 10. So what is a? 10a is equals to 7 over 10. So you divide both sides by 10. So you get a is 7 over 100. Are we together? A is 7 over 100 because we have 10a is equals to 7 over 10. You divide both sides by 10, you get a is 7 over 100, isn't it? Yes. Good. Let us now compare the coefficients of the exponential function. The ones without x. The ones without x. So start. See, this one does not have x. What is the coefficient of this one? See, it is 2k. 2k. See, this one does not have x. Its coefficient is plus 2k, isn't it? This one has x. We don't need it. It is not on the other side of the equation, isn't it? Yeah. Then this other one, see, there's no x here. Its coefficient is negative 7k. We need it. This one, see, there's no x here. Its coefficient is negative 14k, isn't it? So all these are coefficients of exponential 2x. We've collected them. There are how many? This is exponential 2x, exponential 2x, exponential 2x, exponential 2x. This one has x, we don't need. This one has x, exponential 2x, we don't need. We only need where this exponential 2x only is the coefficient we are comparing. You see that? So all this is equals to what? 1 exponential 2x, meaning the coefficient of exponential 2x on this side is this, on the other side it is 1. Are we together? We don't need x exponential 2x, we only have exponential 2x, so that is what we compare, coefficients. Are we together? So what do we have here? 2 plus 2, 4. I have 4 minus 7k, negative 3. Huh? Negative 3 minus 14k, negative 17k. To be equals to that 1, isn't it? Are we together? So what is k? Negative 1 over 17. If you divide both sides by negative 17, isn't it? K is negative 1 over 17. You see, if you compare the ones with coefficient of x, you will equate it to 0, and it means you will not be able to get the value of x because you will find k to be equals to 0, isn't it? When you use these ones with x exponential 2x, because there is no x exponential 2x on the other side of the equation, meaning its coefficient of 0. So if you compare what is not there, you will definitely not get k. Are you seeing that? Oh, this 14, where is it here? It has an x. There's no x here. Oh, when we were multiplying, x was here. And we forgot. So you put it. If x was there, it has to be there. Then it means it is no longer here. It was there. You confirmed from what we brought. It had x. My friend, confirm well what we've written. It was under dv over dx. dv over dx. We had b plus k exponential 2x plus 2k x. Yes, it has x. So go there. So you remove it here, isn't it? So what do we have? 2k plus 2k is 4. 4k. 4k minus 7k? Negative 3k. So we'll have negative 3k to be equals to 1. You are the ones to guide me because with me I'm roughing what I've written, isn't it? So if you divide both sides by negative 3, what do you have? K is negative 1 over, isn't it? So where there is k, we are going to put negative 1 over 3. Where there is b, we are going to put 1 over 10. Where there is a, we are going to put 7 over 100. So can you now go back? Where is that your equation? We also have it. Where was it? Your b. We wrote b somewhere. What did we say b is? It was a plus k exponential 2x. So start substituting the values. Where there is a, what is your a? 7 over 100. Where there is b, what is your b? 1 over 10x, isn't it? Where there is k, what is your k? Negative 1 over 3x exponential 2x. Are we together? So we found the particular integral. The particular integral will never have unknown. We never have those unknown values must be eliminated, isn't it? When you are comparing coefficients, isn't it? So what is the value of y? Y is u plus. So you get y is, what is u? A exponential 5x plus b exponential 2x, then plus b is plus 7 over 100 plus 1 over 10x minus 1 over 3 minus a third x exponential 2x. So this is the general solution, isn't it? But we don't need the general solution, we have the boundary conditions, isn't it? We have the boundary. So those boundary conditions are going to help us to get the value of A and B, isn't it? So start by differentiating this equation. If you differentiate dy over dx is what? If you differentiate this, what do you get? If you differentiate A exponential 5x, 5a exponential 5x, isn't it? If you differentiate b exponential 2x, you get plus 2b exponential 2x. If you differentiate a constant, 0. If you differentiate 1 over 10x, so you get 1 over 10. X goes to 1 if you differentiate, isn't it? Are we together? Then if you differentiate x exponential 2x, that is product rule, isn't it? If you take exponential 2x step, you differentiate x, you get? Yes. So we are going to have negative a third. If you take exponential 2x step, you differentiate x to get 1, isn't it? Then plus, if you take x step, you differentiate exponential 2x to get 2 exponential 2x. So 2 exponential 2x times 2x gives you 2 step, isn't it? Then both of them are sharing negative a third outside. Are we together? Good. After that, you go to the boundary condition. When x is 0, y is negative 1, isn't it? That is in the first equation, isn't it? So where there is x, if you put 0, where there is y, you put negative 1. So you are going to get negative 1 is equals to exponential 0 is 1. Anything raised to power 0 is 1, isn't it? Here you are going to remain with a. Are we together? Then plus b, because exponential 0 is 1, isn't it? Then here plus 7 over 100. Then here, remember x is 0, meaning this one goes to 0, isn't it? Are we together? X is 0, the whole of that disappear, isn't it? So you are done with the first part. So if you simplify this, what do you get? A plus b is equals to negative 7 over 100 coming this side, it becomes negative 7 over 100, isn't it? So negative 7 over 100 minus 1, negative 107 over, use calculator. Negative 7 over 100 minus 1, isn't it? Next one, dy over dx is 0 when x is 0, isn't it? Meaning where there is dy over dx, you put 0, isn't it? So this one is 0 is equals to, where there is x, you put 0, meaning here you remain with 5a, isn't it? 5a plus 2b plus 1 over 10, then negative a third into what? Plus minus 1 over 3 into, where the x you put 0, exponential 0 is 1, isn't it? Where there is x you put 0. So if you put 0 here, everything here goes to 0, because x is 0. So you just remain with a third into 1, which is just a third, isn't it? So plus 1 over 10 minus a third, if you bring them on this side of the equation, you get 5a plus 2b is equals to what? Three over 10. What do you have? So this is plus 1 over 10 minus 1 over 3. 7 over 10. 7 over 30. 7 over 30. If you take it on the other side of the equation already, yes, because it will now be negative a third coming here is positive a third, isn't it? Positive 1 over 10, third coming here is negative 1 over 10. So 1 over 3 minus 1 over 1 over 10. Are we together? That is 10 minus 3 over 30. That is 7 over 30. So what do we do to solve for A? We use elimination, meaning you multiply the first equation by 5, isn't it? So 5 times A, 5A plus 5 times B, 5B, 5 times this you get negative 107 over 20. If you multiply this by 5, isn't it? So eliminate, subtract. This minus this is 0. 2B minus 5B, negative 3B. So go again. 7 over 30 minus negative 107 over 20. 7 over 30 minus negative 107 over 20. That is positive, isn't it? 7 over 30 plus 107 over 20. What do you have? 7 over 30 plus 107 over 20. You have 67 over 12, isn't it? So divide both sides by negative 3. What do you get to be B? Answer divided by negative 3. Negative 67 over 36. Negative 67 over 36. Good. Then you go on. What is now your A? A plus B is negative 107 over 100. So what is A? A is negative 107 over 100 minus B, isn't it? Meaning it is going to be negative 107 over 100 plus 67 over 36 because it is minus negative, isn't it? So that is going to be plus. What do you have? What do you have to be A? 1 107 over 100 plus 67 over 36. 178 over 225. 178 over 225. 225. So what is your solution? Your solution is y is equals to, see this was the solution. Y is equals to A exponential 5x. What is A? 8 over 225 exponential 5x. Then it is plus B exponential 2x, isn't it? Are we together? What is your B? 67 over 36 exponential 2x plus 7 over 100. Go on. Plus 1 over 10x minus 1 over 3x exponential 2x. And that is the end of that given second order ordinary differential equation. So you have y is 178 over 225 exponential 5x minus 67 over 36 exponential 2x plus 7 over 100 plus 1 over 10x minus a third x exponential 2x.